Hello, this is Scholastic Sam with another video for my channel, another chemistry video. This one is the second one you're doing, lesson 1.2, the Bohr model. Let me give you some history. Now, throughout history, there have been many different models of atoms. Now, ever since the discovery, people have been trying to model different atoms and compounds to show what they look like and better understand them. Today, we use Schrodinger's model, also known as the quantum mechanical model. This just states that the electrons and the atoms are 3D, and thus they have width, height, and depth. He also thought the electron clouds were essentially waves. And the Bohr model is the one we're going to be using because even though it was proven incorrect, it's simple and gets some of the main points, especially when talking about bonding. It illustrates that very well, so we're going to be using that one. Now, when we look at the periodic table, we have periods and groups. Now, periods, as you can see, are the columns going up and down, and groups are the ones going left and right. Now, the group of an atom is the amount of electron shells it has, or the amount of rings. This will become clearer, and you will understand it better once we learn more about the Bohr model. And the period is the valence electrons, which is the amount of electrons in the outer shell. Now, when drawing a Bohr model, you just draw the numbers of protons and neutrons in the middle and electrons in the outer shell. Some people like to draw the neutrons and protons with like little circles with a P and N or a plus or something, and draw the electrons with a dash, but we're just going to draw P colon the number, N colon the number, and draw just filled in circles for the electrons. This is the periodic table. You use this a lot in chemistry, and if you didn't in my last video, you should probably pause it and study this for a little bit. Now, the Bohr model. It's a 2D model of an atom with the protons and neutrons in the middle, and the electrons in the ring around it. And like I said, you have the neutrons and protons written in the middle, and the electrons drawn in the outer ring. The first ring has a maximum of 2 electrons, and the rest of them have a maximum of 8. Now, he came to this conclusion using the Bohr model, using previous data and research. He found that electrons, when you shine them through a prism in cold energy, that they absorb they absorb energy and get excited, and that's why they produce this over here on the hydrogen absorption spectrum. But when it's hot, it goes down to something like this on the hydrogen emission spectrum. Now, he thought this was because when they get excited and get more energy, then they go up a shell or out more, also known as the excited state because they absorb energy, and ground state when they release energy. He thought that could explain the excitement, and jumping could explain why the light was shown when it absorbed energy but not when it emitted it. Now, that's some background on the Bohr model, but in chemistry class, you're probably going to have to mainly draw Bohr models. So this is what a Bohr model essentially looks like. You have 6 protons, 6 neutrons, and you draw a circle around that. And then you have the first ring. The first ring has a maximum of 2, like we said, and the outer ring has a maximum of 8, and so all of the other ones. They have a maximum of 8 because, like we said, there are only 8 periods, really, because we don't really count transition metals. Those are unpredictable, and we don't really use them for this. They're not as important and just really cause confusion when drawing Bohr models. So, when you look at the periodic table. So, we can tell it because it has 6 protons. This is carbon, and it's carbon-12. Now also, noble gases, you probably won't see many with 8 on their outer shell before a bond, because those would be noble gases, and they're the most stable, so they're not really going to make many bonds. So now let's go do practice problems. We look at this one. This one, I'm just going to show it to you guys, then our next one will actually do the problem. So this first one, we have carbon-14 with a 2 plus charge. Now, as I filled in here, we see that this is sort of a review too. We see at the bottom here that 6, that's the amount of protons, which denotes the atomic number, which is 6, which we know is carbon. Then we have 14 up here, which is the mass number, and 14 minus 6 is 8, which is neutrons, because neutrons plus protons equals mass. And then we know that carbon has 6 protons, and there's a 2 plus. Now, we mean that the charge is 2, and protons minus electrons equals charge, so 6 minus what is 2? 6 minus 4. So there are going to be 4 electrons. So we know that the maximum amount in the first ring is going to be 2. So you fill up that ring. You don't move on to the next ring until the first one, or until like the previous one is completely full. So we know we filled up that ring, then we move on to the next one, but we don't have 10 yet. We don't have enough to fill out that ring. So we have 2 shells. And we must have 2 valence electrons because we only have 2 left over. Now let's go down and do another one. Now, phosphorus 32. Now, let me see, am I going to draw this? Now we have phosphorus 32. Now, first, we know we want to draw our first ring. Now, phosphorus 32 means it's going to have a mass number of 32, which is protons plus electrons. When we know phosphorus is atomic number 15, so we're going to draw P 15, and 15 plus 17 is 32. Now, we want to figure out how many shells and valence electrons, so we're going to look. Now we have phosphorus. So we go up to our periodic table, we see that phosphorus is in period 5, so it's going to have 5 valence electrons, and it's in group 3. You see phosphorus right here. It's in group 3, so it's going to have 3 shells. So we go there, we draw 1 shell. That's a little low. Whoop. We draw 1 shell. We draw 2 shells. And we draw 3 shells. Now the first one, like we said, has a maximum of 2, so we put 2 there. And then we know there are 3 shells, meaning that the second one has to get completely filled up. So we put 8 here. 1, 2, 3, 4, 5, 6. My poor drawing. 7, 8. So then we know that there are 5 on the outside. So we go 1, 2, 3, 4, 5. Now that's how you draw it for phosphorus. You know that we used our knowledge of it's phosphorus 32. We used our knowledge of protons and neutrons. That one's easy. You just look at the symbol or the element to find the protons, and then you can easily use the mass, or your teacher might give you the neutrons. And then you just draw a circle around that, and then you draw your first ring with a maximum of 2, and then the next one, which is a maximum of 8, and the rest are just maximums of 8. Because that's the most amount of electrons that can be on them. And so we looked at our period, we saw that there were 3, or we looked at our group and saw there were 3 shells, meaning that we draw 3, and we know that the first 2 are going to fill up, so we can automatically know the first one we're going to draw 2, the second one we're going to draw 8, and we saw it was in period 5, which means that there will be 5 valence electrons, meaning 5 on the outer shell. Now, if you have any questions, comments, or concerns, you can email me at sammypaulk@icloud.com. Please like and subscribe. It helps me grow the channel and helps this knowledge reach more people. And please turn on post notifications so you can get easy knowledge and help with your classes to ace high school with ease, because I know math and science courses can be hard. But here, I make them easy for you, and that way you can do well. And I'd like to give a shout out to Dr. B, my chemistry teacher, for teaching me all this knowledge. If she is watching this right now, I wish her a speedy recovery on her foot surgery. And I hope, so remember, please like, subscribe, turn on post notifications. Join us for our next unit on reactivity, our next lesson on reactivity. And we will continue doing chemistry, algebra, all these math and science, and anything that really you guys need. So remember, or bye, and thank you, and remember, knowledge is power.